Guys, this question actually deals with only the qualitative side. But think about it. Even without numbers being involved, how interesting question can be asked. Okay, let's go ahead. Perfect. So, 1 and 2 are attracted to each other. 2 and 4 are attracted to each other. 4 and 1 are attracted to each other. The red bold line is my code for attractive force. 2 and 3 are repelling each other. The dotted orange line is my code for repulsion. 4 and 5 are also repelling each other. In order that two charges repel each other, in order that the two charges repel each other, they must be of the same charge. They must be charged and of the same charge. Agreed? Perfect. That means 4 and 5 must be of the same charge. 2 and 3 must be of the same charge. Right? Perfect. In order to attract two charges, both of them must be, there is no must be. Don't fall for that. You already know this. You do not need two charges to be actually charges at the first place to attract. Go back to the Greeks. Rewind 2000 years back. Remember the glass rod? When this glass rod, let's say positively charged, when this glass rod was attracting a dry leaf or a piece of paper, you think that leaf or paper was charged? No. What happened? This paper, let's say, was kept, and in the vicinity of the glass rod, what happened? Induction, polarization. The electrons of the paper came closer to the side where the rod was. Absence of electrons created a positive charge on the other side. This process is called polarization. And now, can you see the negative charge on the paper and the positive charge of the glass rod are closer, lesser distance as compared to the positive charge. Lesser distance means greater magnitude of the force. That's why the attractive force between them wins as compared to the repulsive force, and the net result is attraction. Lesson learnt. You don't need both the substances to be charged at the first place to get attracted. Attraction can happen between a charged substance and a neutral substance too. However, for repulsion, you need both of them to be charged, and on top of that, you need both of them to have same charge, like charge. Let's revisit the question actually in the light of this new knowledge. So, the bold red lines represent attraction and the dotted orange lines represent repulsion. So 2 and 3 repel each other, but they are charged and of the same nature. Let me call that nature capital A. So 2 has A nature charge, 3 also has A nature charge. 2 and 4, however, are attracting each other. That means the option of 4 being neutral is gone. 4 must be charged. Right? Why? Because 4 is being attracted to 2 at the same time being repulsed by 5. If I only considered the attraction between 2 and 4, 4 could have been neutral. But 4 is repelling 5 at the same time. These two observations put together tells me that 4 not only is charged, it is of opposite nature to 2. Hence, the nature of charge on 4 must be B, opposite to A. Now, in question, the ball 1 is getting attracted by ball 2, which is charge A, is getting attracted by ball 4, which is charge B. If the ball 1 is being attracted to both kinds of charges, clearly it itself must be what? Neutral. Hence, the nature of charge on ball 1 is actually null or neutral.